Hi all, this is nghosh and I'm here to present my experiments with temporal difference learning, and it is based on the 88 paper by Richard Sutton. Well, the first experiment tries to prove that for a sufficiently small alpha, the weight vectors will all converge, and it will converge to the same final value under the repeated presentations paradigm. In my case, I had to experiment a lot, and finally an alpha less than equal to 0.02 led to converging of the weight vectors, and the experiment went pretty well. I was able to reproduce the results in the paper, apart from the fact that my lower bounds for lambda is equal to 0 was around 0.11 as opposed to 0.19 in the paper. And the interpretation of the results, a lot of people might expect the withdraw of procedure for lambda equal to 1 to perform the best, but the idea is the withdraw off performs good and minimizes error on the training set, but not necessarily on the when you're predicting future experiences. Well, the second experiment tries to show the effect of the learning rate alpha on the RMS error when a training set is presented just once and not repeatedly to the learning procedure. And these results were accumulated for or averaged over 100 training sets for different values of lambda and alpha. Now my results are pretty consistent with what is shown in the paper, but particularly for alpha less than equal to 0.5. The interesting part here is for the moment alpha goes beyond zero point 0.5, my results actually diverge a lot, and lambda is equal to 1 and lambda is equal to 0 absolutely shoot up. My interpretation here is possibly when alpha is greater than zero point 0.5, you start incorporating the results, your immediate learning more, and in that process you also incorporate the errors in your immediate learning. Well, experiment 3 tries to find the best error level for a given lambda for any alpha, and in my case I found the best lambda to be 0.2 as opposed to 0.3 which was shown in the paper. But I was able to prove that all the lambdas less than 1 perform much better than lambda equal to 1. Now, interpreting the results, the idea is there's a middle part between zero point 0.2 and 0.7. For higher lambdas, you not only do propagate the learning, but you also propagate the error which comes along with the learning. And for lambda is equal to 0, the propagation of the learning is just a little too slow. Hence, you generally end up with a best lambda somewhere between 0.2 to 0.7.